Hi students, we are continuing exercise 11.3. 11.3 problems in trigonometry. Problem number 4. Previous problems we have done in the earlier lecture, video lecture, you can refer to that. In this problem, if tan A is equal to cot B, where A and B are acute angles, that is less than 90 degrees. So what they are asking, prove that A plus B is equal to 90 degrees. This is the question. So what they have asked, tan A, they asked A plus B equal to 90 degrees we have to show, and what it is given is tan A is equal to cot B. So we know the relation tan of 90 minus theta is equal to cot theta. So in the given problem, the RHS cot B can be replaced with tan 90 minus B. Tan 90 minus B is nothing but cot B. Okay, so RHS cot B is replaced with tan 90 minus B, and LHS we have it as tan A. So tan A is equal to tan 90 minus B, and here both the left hand side and right hand side we have tan, and we have this in the parenthesis A and 90 minus B. So this we can equate. A is equal to 90 minus B. If you bring this 90 B on the left hand side, this minus B becomes as plus. So we get it as A plus B is equal to 90 degrees. Hence it is proved. What they have asked is show that A plus B equal to 90 degrees. Right. Another problem they asked, if A comma B and C are interior angles of a triangle ABC, then show that tan of A plus B by 2 is equal to cot C by 2. So what they have given, ABC are the interior angles of a triangle ABC. Then they are asking to show that tan of A plus B by 2 is cot C by 2. So here we can start that. If you take a triangle ABC, we know that sum of the interior angles of a triangle, that is angle A plus angle B plus angle C, is equal to 180 degrees. This simply we can write it as A plus B plus C is equal to 180 degrees. And just they've asked in the problem that you have to be careful that A plus B by 2, and right hand side we have in the brackets C by 2. So we keep A plus B on the left hand side and take this plus C. On the right hand side we get 180 minus C, and now divide both sides with 2. divide both sides with 2. So what we get here is a plus b by 2 and 180 minus c divided by 2. So RHS 180 by 2 separately we can write for 180 and c, that is 180 by 2 and c by 2. We know that 180 by 2 is 90. Okay, 2 nines are 18. 2 nines are 18 and we get it as 0. 90 less. 180 by 2 is 90 minus c by 2. And we get a plus b by 2. So suppose if you take tan on both sides, taking tan on both sides, what we can write here is tan of a plus b by 2 is equal to tan of 90 minus c by 2. Okay, and we know that tan of 90 minus theta, what it is? Tan of 90 minus theta, cot theta, that is cot c by 2. Here in place of theta we have c by 2. So on the left hand side we have tan a plus b by 2. So this is what they have asked to prove, hence it is proved. What you have to write at the end, hence it is proved. Right. Another problem of this exercise we have, what they have asked is express sine 75 degrees plus cos 65 degrees in terms of trigonometric ratio, in terms of trigonometric ratios of angles between 0 degrees and 45 degrees. That is what they have given here. Express this sin 75 and cos 65 in terms of new angles which lie between 0 and 45. So sin 75 and cos 65 we have to replace with new angles. So we can write here sin 75 it is given plus cos 65. So this is equal to sin 75, we can write it as sin 90 minus 15 degrees. Sin 90 minus 15, and cos 65 we can write it as cos 90 minus 25 degrees. 90 minus 25 is 65. 90 minus 15 is 75. Okay, and we know that sine of, otherwise you can, I'm writing again here, we know that sine 90 minus theta is cos theta. This we know that sine 90 minus theta is cos theta and cos 90 minus theta is equal to sin theta. So we can replace here sin 90, these two are the formulas which you have to remember. Okay, these are the formulas. Now in the given problem that they have asked sin 75, we have replaced this 75 degrees angle with 90 minus 15 and 65 with 90 minus 25. So we can write it as Sin 90 minus theta, how we can write? Cos theta, cos of 15 degrees, right? Plus, how we can write this cos 90 minus theta as sin theta, that is sin of 25 degrees. That is what they asked in the problem, that for the given sin 75 and cos 65, they are asking to express this in terms of new angles of which lies between 0 and 45 degrees. 0 and 45 degrees. So here if you see, finally what we have written is, we have written the given expression in terms of cos 15 and sin 25. This 15 and 25 are the angles which lie between 0 and 45 degrees. Between 0 and 45 degrees. Okay. This is the end of the exercise 11.3. Next class will start trigonometric identities. Very important identities. Okay. Please share and subscribe. And also you also continuously watch these videos. Next class we will start trigonometric identities and the exercise 11.4, which is the last exercise of this chapter. Thank you.